Welcome to our sixth and final part of chapter 4. In this one, we just talk about a type of stereoisomerism that we're going to cover in much greater detail in chapter 5, but it brings in a little bit of vocabulary. For di-substituted cycloalkanes, and so this only works if it's a di-substituted. If you have 3 or more substituents, it doesn't work. And the di-substituted, it has to be substituents on different carbons in the ring. There are 2 types of isomer that we're going to see that we haven't seen yet. They're not constitutional. They are connected the same. You see pictures of them with Hayworth projections. Another way we could draw this would be like this. These are 1,2-dimethyl cyclohexane. Right? Both of these are 1,2-dimethyl cyclohexane. But they are not the same compound, so how can they have the same name? Right? There is no way to turn this, flip it, rearrange it, spin it around in a washing machine and take it out that will turn it into this one. Right? In one case, the methyl groups are on the same side of the ring. They're both up, they're both wedged. They could both be dashed, they could both be down, but whatever, they're the same side. Right? And in the other molecule, one is up and one is down. And there is no way to get from here to here without breaking bonds. And you cannot break bonds to be the same compound. And it turns out these 2 compounds actually have different physical properties. And so we come up with some different naming schemes to handle that. Cis can go out in front of the name. It means that the 2 substituents are on the same side. Trans substituents are on opposite sides. So in reality, while these are both, if I gave you this to name, all you could tell me is 1,2-dimethyl cyclohexane. You don't know which stereoisomer you have. But if I give you the wedges and dashes, now you can be more specific. This one is cis 1,2-dimethyl cyclohexane versus trans 1,2-dimethyl cyclohexane. This is IUPAC nomenclature, so it's not a common name. There are other ways to handle this, but this is a common way to do it when it's a di-substituted cycloalkane. Now, it would not make sense to use it for 1,1-dimethyl cyclohexane here, because one is going to be wedged and one is going to be dashed always. You can't have them on the same side on the same carbon. So this only applies, right? So only applies if the substituents are on different carbons on a ring and there's only 2 of them. Right? Now, the stability of the conformation, the conformations of the stereoisomers is different, right? In cis, one is axial, one is equatorial. These are equal energy, right? There isn't a more stable and a less stable. Axial methyl, equatorial methyl, axial methyl, equatorial methyl. But in the trans stereoisomer, interesting. They're both axial versus they're both equatorial. This one is considerably more stable. And so you'll have more of one chair versus the other. Something just to note, this word stereoisomerism, that is what all of chapter 5 is about. It is an isomer where the connectivity is the same, right? Those methyl groups, connectivity is the same. Those methyl groups are still connected to carbon 1 and 2 in the ring. There's no change in connectivity. But there is a different orientation in space So a different spatial arrangement that you can't just twist or flip to get back and forth between. In this case, we are locked in place because it's a ring. They're single bonds, and single bonds can usually rotate, but since it's in a ring structure, you can't rotate it without breaking the ring open. Now, 415 is about polycyclic systems. I am not going to ask you anything about polycyclic systems, but you have the same issues when you have fused 6-membered rings. You get a bunch of connected chairs, and it's very common to see these 6-membered rings in polycyclic structures. And that's one of the reasons why diamond is so strong. It's all carbon bonded to other carbon, no ring strain, no angle strain, very strong sigma bonds. And that's the end of chapter 4. I will be putting up a practice for you throughout the week. You come see me in office hours. But this wraps up the material that'll be covered on exam 1 next week.